In a bold proclamation that captured the attention of the global scientific community, researchers have announced the identification of a celestial object unlike any previously recognized. NASA, renowned for its pioneering role in space exploration, disclosed that this discovery is compelling not only because of the object's size and position, but also due to an astonishing characteristic. It emits a form of light that appears to be artificial. Could this finding mark the beginning of revelations that may forever alter our understanding of the cosmos? Is it possible that we are now one step closer to confirming the existence of life beyond Earth? By delving into NASA's trailblazing research and unraveling the data behind this phenomenon, we inch closer to unveiling the extraordinary truths behind this mysterious event. The journey into this discovery began in 2007 when NASA launched the ambitious Dawn mission. The spacecraft was designed to explore two of the most intriguing entities in our solar system, the asteroid Vesta and the dwarf planet Ceres. Powered by three innovative ion propulsion systems, Dawn first conducted a 14-month survey of Vesta, the second-largest body in the asteroid belt. The mission returned a treasure trove of high-resolution images and geological data, offering unprecedented insights into Vesta's complex surface and diverse history. Upon completing its mission there, Dawn made a bold leap toward its next target, Ceres, something previously unimaginable using traditional chemical propulsion methods. Thanks to its steady and efficient ion engines, Dawn escaped Vesta's orbit and embarked on a journey toward the largest body in the asteroid belt. Ceres, discovered in 1801 by Italian astronomer Giuseppe Piazzi, occupies a unique position in space. For a brief period, it was considered a full-fledged planet before being classified as the Solar System's smallest known dwarf planet in 2006. Measuring approximately 950 kilometers in diameter, Ceres is both the largest and most massive object in the asteroid belt between Mars and Jupiter. What makes Ceres so captivating isn't just its size, it's the planet's strange and luminous characteristics that have sparked widespread intrigue. Before the Dawn mission, our view of Ceres was limited to blurry, low-resolution images captured by the Hubble Space Telescope. But when Dawn approached and began sending back crisp, close-up photographs, scientists were stunned. Scattered across Ceres' surface were brilliant reflective spots, most notably in a large crater named Decatur. These glowing patches immediately stirred curiosity and speculation. The Dawn mission had a broader purpose beyond capturing images. It aimed to deepen our understanding of how planetary bodies form and evolve, especially with regard to the role of water. The bright spots on Ceres were a mystery. Could they be made of reflective ice? Or perhaps salt deposits left behind after the evaporation of briny water? If so, it might suggest the presence of cryovolcanism, a rare geological process where water or brine erupts instead of molten lava. As more data came in, it became clear that these lights were not isolated phenomena. The largest and brightest among them, located in Decatur crater's so-called Spot 5, was actually a cluster of reflective regions. This observation supported the idea that Ceres might still experience geological activity today, with underground reservoirs of briny liquid pushing to the surface and sublimating in the vacuum of space. Ceres distinguishes itself from its asteroid belt neighbors not only by its brightness but also by its composition. While most asteroids are dense, rocky, and metallic, Ceres is more akin to a comet. It has a porous outer layer made of rock and ice, as well as a subsurface that possibly harbors significant amounts of water. In fact, scientists estimate that about half of Ceres' volume may consist of water ice. The planet's internal structure is thought to include a rocky mantle and a core surrounded by salty, icy layers. This unique makeup suggests that Ceres could once have hosted, or might still host, pockets of liquid water, especially if the core was warmed by radioactive decay in its early history. If confirmed, this would place Ceres in a special category of celestial bodies that may possess the necessary conditions for life. Adding to its mysteries, researchers have detected ammonia-rich clays on Ceres' surface. The presence of ammonia implies that Ceres may not have formed in its current position. Instead, it likely originated in the colder, outer regions of the Solar System before migrating inward. Ammonia lowers the freezing point of water, making it possible for salty liquids to remain fluid even in the frigid conditions of space. This further supports the theory that cryovolcanic activity could be ongoing or have occurred in Ceres' recent past. The planet's composition, geological diversity, and potential for internal heat all hint at a world far more dynamic than previously imagined. These findings not only change our perception of Ceres but also offer vital clues about the formation and evolution of other icy bodies across the cosmos. Cryovolcanism itself is a rare and remarkable phenomenon. Unlike the typical volcanic eruptions we see on Earth, cryovolcanoes spew substances like water, ammonia, or methane. These materials can exist in a liquid or gaseous state under extremely cold conditions. On Ceres, this process allows salty brines to rise through cracks in the surface. Upon exposure to the vacuum of space, they rapidly sublimate, transforming directly from liquid to gas, leaving behind bright, reflective salt deposits. The brightest of these, within a crater's spot 5, exhibits changes in brightness over time, suggesting active or recently active geological processes. These shimmering patches are not isolated but distributed across various regions of Ceres, indicating widespread cryovolcanism and challenging the long-held assumption that Ceres was geologically dead. As Dawn continued its mission, it delivered increasingly detailed views of Ceres' cratered surface. Each impact scar and luminous anomaly added a chapter to the story of this evolving world. What was once viewed as a relic of the early solar system has now emerged as an active and possibly habitable environment. The shining patches, especially those in a crater, have remained focal points of scientific curiosity. Some experts theorize that they could be markers of subsurface reservoirs, possibly containing water or briny mixtures. If true, this would carry profound implications, not just for Ceres, but for our broader understanding of what makes a planet or moon capable of supporting life. The implications extend beyond this single dwarf planet. Studying Ceres offers a lens into the processes that govern other icy worlds, such as Europa, Enceladus, and Titan. By understanding the minerals and compounds found on Ceres, like ammonia-infused clays and reflective salts, scientists can make better predictions about similar environments across the solar system and beyond. The evidence of cryovolcanism on Ceres opens exciting new pathways in planetary geology, providing a new framework for interpreting geological activity on distant exoplanets and frozen moons. It challenges our assumptions about where life could exist and compels us to reconsider planets once dismissed as barren and lifeless. NASA's Dawn mission stands as a monumental achievement, a testament to human curiosity and technological innovation. What we've learned from Ceres has already revolutionized our views on planetary evolution and the complex dynamics of water in space. These glowing regions on the dwarf planet's surface are no longer just optical curiosities. They are windows into ancient and potentially active processes that could one day reshape our understanding of life's potential beyond Earth. As we look to the future and plan new exploratory missions, the possibility of even greater discoveries remains within reach. In the end, the story of Ceres is more than a tale of one small world. It's a reflection of our ever-expanding quest for knowledge. The shimmering patches on this icy dwarf planet may represent only the beginning. With every mission, every image, and every data stream, we edge closer to answers that once existed only in the realm of science fiction. Could microorganisms be thriving in Ceres' hidden reservoirs? Might the frigid worlds we once ignored be harboring life as we've never known it? These are the questions that now guide our journey into the universe, and perhaps, one day, toward our greatest discovery of all.